Yeah, hey everyone. Today we're just going to go through the workflow of importing some data into Trimble Business Center and running a few processes in it. We're going to create a surface of a kind of forested area as well as some contour lines. So first thing we want to do is open a new project here in Trimble Business Center. And then I'm going to change the coordinate system to the coordinate system that I've exported the data from Aura in. So I'm going to click on change. And I know the EPSG code is 3006. If I select this one though, it includes a geoid model. The data that I captured, I haven't converted it to orthometric heights yet. So it's currently still in ellipsoidal heights. So what I'm going to do is search in here for Sweden. And I'm going to select no geoid model. So that means that the data is going to come in as ellipsoidal as the data actually is. And then I'm going to convert it to orthometric heights using Trimble Business Center. So we'll click on finish. That will then set the coordinate system in this project. What I'll quickly do now is save the project. And then I'm going to drag and drop the coordinated data set that I have into Trimble Business Center. Here it's going to prompt whether the data is georeferenced or not. This one is, so I'm going to select this georeference point cloud, click on OK, and then we'll start importing the data. Okay, so now that data has been imported here, if I open the 3D view, be able to have a look at what's been captured. This is where I took off from. This was captured with a drone, and it had RTK corrections for the whole flight. So what I want to do next is convert this data to orthometric heights. What I like to do is a quick check is have a check on a point somewhere here, and we can see the height is roughly 73. Then we're going to go back into the project settings, and we're going to change our datum to include geoid model. So now we're going to select this geoid model here, click on finish, and go OK. So now if we come in and just check a point roughly in that same area, we can see the heights have changed roughly 22 meters or so. So this is now the elevation, and we can still see the ellipsoidal height of the same point here. So it's a good check to verify the data is now in orthometric instead of ellipsoidal. Then what we want to do is click on point cloud, the point cloud ribbon, and we're going to classify this data set. So this uses a deep learning algorithm. You select the method in which the data set was captured. So this is outdoor and aerial. We're going to select what we want to classify. We're going to classify this point cloud, and then I'll click on classify and refine. Okay, so now that has finished classifying the data, so we can check what areas they've been classified into. As you can see around here, this has been put into the noise layer. There's both, me walking around, car, maybe some equipment that was on the ground as well. So that is all in the noise. We can turn that off. We have medium vegetation is this lighter colour green. So if we turn that on and off, we'll see it's done a pretty good job of that. We have high vegetation, which is the majority of the vegetation in this point cloud. We do have some blue here, which is building. So I would say that that is incorrect. What we can do with that is I can select this data and I'm going to go add to region. It's ground. So now it's disappeared because the building layer is turned on. If we go to ground, it's now in the ground layer, which is where it should be. So other than that, I don't think we had anything in dividers. Some stuff out here maybe. Looks like that is either never classified, and some poles and power lines, I think. But they're a long way away from where the data was actually captured, so I'll just change this back to true colour. The flight itself was only in kind of the centre of this coloured area, so this data all the way out here is very unreliable, I guess. Okay, so what I want to do next is I'm just going to turn on the ground layer, and I'm going to thin this data down a fair bit. So I'm going to click on the advanced filtering. I'm going to select the ground layer that I want to filter further. Filtered. I'm going to increase the sample size, so there'll be 1 point every meter, and I'm also going to keep a dynamic sample size, meaning when there's a change in elevation, there can be more than 1 point every meter. So I'm going to make this minimum elevation change can be, say, 1, maybe 0.75. And then we can drop down our dynamic cell size down to 0.5. On filtering. For this, I'm going to create a bare surface model, so I want the minimum elevation. And we're going to keep the actual location. And I'm going to run this filter. Alright, so now we have the ground filtered layer is finished. And as you can see, it's a fair bit more sparse than the previous ground layer that we had. So if I turn on the previous one, looks like that, and the filtered one looks like that. So what I'm going to do now is create a surface from this filtered ground layer that you can see. I'm just going to call it ground 1 because I'm going to do this more than once, and I've already selected the surface there. So we're going to apply that. And here we have the surface triangulation of that filtered layer. Turn off these points so we can just see the surface itself. So it's done a pretty good job of sort of maintaining some of these features. You can see the road coming through here quite clearly, as well as a good pickup underneath all of these trees. Remember, I turn on the high vegetation. That forest is fairly dense, and we got good coverage under all of it. These points further out are very sparse, which is why some of these points were quite high, only capturing trees and nothing underneath the canopy. What I'll do shortly is trim the triangulation so we don't have any of that information in the final output. One thing I do want to do is I want to draw the centre line of this road coming in, and I'm just going to make the edges of the road a bit more pronounced. And for this particular example, maybe it's not so important, but you could do something similar for curb and channel or other structures that have quite defined features to make sure that you don't end up with the rounding of surfaces, or rounding of the edges when you want to have quite a sharp defined surface. So what I'm going to do is draw the centre line of the road. Centre line, and I'm going to create a new layer called road. And I'm just going to put in an arbitrary height of 50 meters for now. Close that. So what I want to do now is drape that surface on top of drape that center line on top of the surface that we've created. So I'm going to click on change elevation, surface elevation. First I'll select the line that I want to change. And we're going to drape it on ground 1. So now if we have a look at this in 3D, you can see that line is following the contour elevation of the road. Then what I want to do is offset, close this, I'm going to call it road edge. It's going to put this in the road layer. Select the center line, that's what we want to offset, and we're going to do 2 meters. First we're going to do to the right and then to the left. So apply that, it's created a line there. Make sure we select the center line again. And if we wanted to apply a vertical offset to have a bit of camber on the road, we could easily just add a number in there to decrease the height of the shoulder of the road. So now we have a polyline, or 3 polylines that reflect the road. It's not perfect, but for the example that I'm using, it'll be fine. And then so what we're going to do is I want to filter out the points from this ground surface level. Let me turn up the size of these points. So I want to filter out the points that are within these, the area of these lines that we've created. So when we do a triangulation, it's going to use these lines and create a very sharp edge with a proper break line. So I'm going to click on this, filter point cloud, filter by CAD line or alignment. What we're going to do is we're going to filter by the center line. Point cloud we want to filter is this one that we've already filtered previously. And we're going to do it by distance. So at the moment, we've got the center line and then these other two lines are 2 meters either side. So let's filter out everything 2.5 meters either side of our center line. So I'm going to compute that. So you can see it's changed colors of those points in the middle. If I turn off that layer, we now have a point cloud with just these lines through here. So we'll get a very clean and crisp triangulation through that area now. So now I will rerun the surface. Let's call it ground with road. And select the points. I'm going to hold down Control, select these 3 lines as well. So it says we've got a total of 4 different objects that we're objects that we're going to use, the points and the 3 lines, and then turn off the road layer. So now we have a triangulation with those, the kind of the bare surface model and this crisp road that we've cut into it. Like I said, it doesn't have to be a road, it could be a curb and channel, for example. But this allows you to use those break lines and sort of have a very clean cut data set. Final thing I want to do is trim this surface because there's a lot of points out here that aren't so reliable. So what I'll do is let's change this to something like that. I can see where the points are dense and therefore reliable, and not so dense out here. So I'm going to create a boundary. So now I'm going to start drawing the polygon that I want to clip my surface to. So we've now drawn that boundary polygon. I'm going to go to surfaces and surface boundaries. So I'm going to use that surface, and I want to select the boundary line that I've just drawn. I'm going to click on Add. So now if we have a look in the 3D view, turn on the round road surface, and I'll turn everything else off. You can see that's been cropped to that boundary surface that I've created. And then what I can do is create some contours as well to this surface that we see here, the kind of nice clean one without the outliers on the fringes of the capture. So that's the surface we want to create the contours on. To align every half meter. I'm also going to create a new layer here. Smooth them somewhat between the labels. Let's say we'll have a label every 100 meters, and then I'm going to click on OK. Oh, actually, let's go. Yeah, half meter will be good. So here we go. So from this you can see, yeah, it's used the road strings well. You can clearly see where the road is along just looking at the contours. Obviously I didn't have any camber or super elevation on the road, so those lines go directly across it. And if we turn everything on, you'll see essentially what we started with. So this capture was done 100 meters above ground level, so yeah, quite a stretch to get enough data underneath this dense canopy, but it's done a good job, and it's allowing us to create a nice digital elevation model to be used for future planning. Anyway, hope this is helpful, and if you have any questions, feel free to reach out. Thank you.